Hello everybody. Today I am going to start the 2D top-down tutorial series. I am Ao, the lead developer of AOCane, and today we're just going to cover a couple of things. We're going to talk about simple player movement, a simple AI to follow the player, and then also going to make an interaction between the enemies and the players. But before any of that, I have to get my scene set up. So I made a couple of folders here. I did art, audio, we might cover that. And then I also made a script folder. And then before anything, I would like it if you went to your package manager and you go to the Unity registry tab and then search for input. This is going to bring up the input system. This is the new input system from Unity. It just links up your controls to your game a lot easier and a lot simpler. And after you install that though, make sure to restart your client, otherwise it won't work. And then once you get Unity back up and running, you can keep following along with the video. But yeah, from there, let's go ahead and go to our project settings. And then go to editor, scroll all the way down, and then in enter play mode settings, go ahead and hit enter play mode options and just check the top box. All this is going to do is when you go to game and you hit play, it's going to not reload your whole scene. So it just makes testing things and going about things a little bit quicker. Alright, so with all of that done, we're about ready to get started. Let's see. So we are going to go back into scene. We're going to create an empty object. And I'm going to name mine player. You can name yours whatever you want to, but this is going to be the object we're controlling. On that, I'm going to right click. I'm going to hit 2D object, sprites, and I'm going to make mine a circle. And what this is going to do is give us a circle sprite under our player. So the circle sprite comes from the sprite renderer. The sprite renderer can do a couple things. We can change the selected sprite we have on it. We can just choose a bunch of random stuff here if we wanted to. But I'm just going to keep mine as a circle for now. We can also change the color. I'm going to change mine to a nice bluish green because that's my favorite color. Along with that, we have the ability to flip our sprite. That doesn't really matter too much right now for us. There's also additional settings in our sorting layers, but we'll come back to that in a sec. And then I'm going to make another object, and that's going to be our follow enemy, just a really basic enemy. It's going to follow us around. And then along with that, do the same thing again, and I'm going to do 2D objects, sprites, and circle. And that's just going to give us another circle. Alright, and then with that, you'll see that our enemy circles overlapping in a weird way, and I'll show you something real quick. The newest object we make is always going to overlap on top, so we're going to go over to our order in layer, and we're going to change that to 2, just to make sure that our player is always on top and not getting covered up. And then I'm going to change the enemy to 1, just to make sure they're right behind them. And then that was just for an example's sake. I'm also going to change the color of my enemies, like a nice purple magenta, and we'll go from there. With our enemies, our goal here is just to make our player move. With that, we want our enemies to follow our player to move, and that's what we're going to try and get done today. So to start off, we are going to need to create an input or action. What are they called? Input actions. And we're going to need to do a new input action. It's at the very bottom, and I am going to name mine player controller. And from that, we can click into it, and this is going to bring up the input action UI. And from here, we can make a new action map. So I'm going to click on the plus button, and I'm going to name my action map player, because this is all of our controls related to the player. And then from here, we can do new action. And from there, we just have to, I'm going to name mine movement real quick. From there, wait a second here. We can change our action type to a value, and then change it to any. And then from that, we're going to do add up, down, left, right composite. And that's just going to give us what we need to set up a WASD control schematic. So I'm going to name mine WASD, just because that's what it's going to be. I can get rid of that other binding. And now to set my control, I can click on this. Here, let me show you again real quick. So I can click here, and then to do that, I click on that little gray box. It's kind of behind the thing because the UI is broken for now, but we hit that, and then we hit the key we want, and that's going to be S for down, and I'm going to continue to do that for all of the other ones. So I'm going to do A left and D right. And that'll be everything for the WASD keybinds. From that, I'm also going to make a new binding, and I'm just going to set it to gamepad left stick, and that's just going to be our controller for like Xbox or PS5 or all of the different controller types. And from that, I think that's everything we need. Yeah, I'm going to hit save asset, and that's just going to save our settings, and I'm also going to turn on autosave just in case we edit it later. And that is all we need for this for right now. Yeah. And then after that, we are going to go to generate C# class. And what this is going to do is make a script for us that our player movement is going to relate to. Gotta let it compile here. So that's going to make our player controller script, which we're going to not put on our player controller, but our player movement script is going to use. So going on from that, we are going to go to our player, and I'm going to add a couple of components. So I'm going to hit add component, rigid body 2D, and this is just going to link up our player to the Unity physics system. This is how I like to do a lot of my movement, but we're going to have a little problem here just right off the bat that we'll have to nick in the butt. But if I go to game and I hit play, you'll see that my player's falling, and you can see that I have a gravity scale on the right side. So to fix that, I just have to set my gravity scale to 0, and then my player won't fall. But from that, that's an easy problem fixed, and we can go add component, and we're going to do a 2D circle collider because we have a circle and we're working in 2D. And then you can see that our collider is not really lining up. I just have to realign the sprite really quick. With that done, should be all good. You can see it lines up right. And then from there, I think we have all of the things we need to start making the player movement script. So I am going to right click in my scripts folder, create, and I'm going to make a C# script. And I'm going to name this one player movement. And wait for Visual Studio to boot up here. My Visual Studio is always a little bit slow, but that's okay. So I'm just going to get rid of all of the middle bits here. Don't need any of that. And I'm going to start off making a couple of variables. And I'm going to start with a serialized field, and I'm going to name it private, or not name it, but I'm going to make a private float, and I'm going to name it speed, because this is what we're going to use to control our players' move speed. I'm going to make another serialized field, and that's going to be a private rigid body 2D, and I'm I'm going to name it RB2D, just a simple naming scheme. And then I also need a private player controller, and I'm going to name this PC. And that's just going to be whatever you named your input actions over there. So it could be different for you. But I'm going to then make a private vector2, and I'm going to name that direction, because this is going to be the direction we're reading in from our PC. And then I also need a private void awake. And inside the awake, you don't necessarily need to do this, but I like to, just as a bit of a fallback. Well, actually first, let me do, we're going to do PC equals new player controller, and we're going to make this is a player controller that we are going to reference. So just declaring the variable doesn't make it, so we have to make one when the game starts. And that's what we're doing with PC equals new player controller. And then we need to do PC.enable, because by default in Unity, things are set to false or set to turned off when we make them. So we just have to enable it. And that will fix any problems that would arise. And then you don't need to do this part, but I would recommend it just as a bit of a fallback. Is I'm going to do rigid body 2D equals gate component rigid body 2D. And that means if we forget to assign the rigid body 2D in the Unity client or the Unity editor, it'll do it for us. So now I'm also going to do a private void update. And inside this, we just have to write, I think it's just one line. Just direction is equal to, and we're going to say new vector2, because that's what we're reading in for our input, and we're in 2D, so we only have the X and the Y axis. And from that, we can read in our values from our PC. So I'm going to do PC.player.movement.read value, and we're reading in the vector2 because we're in 2D and only working with the X and the Y axis. And since it's a vector2, we have a float, which is X, and a float Y. So we're going to read in the X value first. And then after that, we're going to read in the Y value. So I'm just going to copy and paste this real quick. And after that, I'll change the Y, or the X to a Y, I should say. So with that done, we're now taking in the input and we're reading it into our direction. After that, we're just going to do private void fixed update, and I'll explain the update difference between update and fixed update in a second here. But we're going to do rigid body dot velocity equals, or direction times speed times time dot delta time. Let's see here. Oh, there we go. So now that it is equal, what this is going to do is set our rigid body velocity equal to our direction times speed times time dot delta time. And why we need to do it in fixed update versus update is to keep our gameplay consistent, so it doesn't rely on whatever system a person has. It just makes it rely on the game settings, so no players are at an unfair advantage or something of the sort. It's the same reason we're doing time dot delta time. And then direction times speed is just going to make our player move about the speed we want to control them at. So over here in the editor, I'm just going to drag the script on, and then I'm going to set our rigid body to our player, and that's just going to grab the rigid body 2D from the player up here. And then I'm also going to set our speed to something like 180, just to give us a good starting value. And if I hit play, you can see that our player is going to start moving. And with that, you'll see that it kind of just floats through the enemy, because we haven't made any colliders for the enemy or anything like that, but we do have some working player movement. So, real quick, you don't have to do this by any means, but I just want to change my color to black just because I think it looks cool. It looks a little bit spacey almost. But obviously we'll make some actual visuals in probably the next video. With that said, we can continue on, and I think we're going to do the enemy AI. And to do that, first, we're going to add a couple things, probably just a collider. We'll add a collider, circle collider 2D, same as the player. And we'll see now, we'll start, give me one second right here. Oh, you can see our collider's not lining up with their sprite again. So if we just set our sprite to 0, 0, 0, if I, yeah, we're just gonna go on to the follow enemy AI. So I'm gonna make a new C# script, and I'm gonna name it follow AI, and it's gonna be a fairly short script. We just have to write a couple of things, and our enemy will start moving. And we could do this a couple of ways. We could make our enemy move with the physics system, or here, let me change this really quick. It's gonna bother me if I don't, but there we go. We can see they're both lining up, and it'll bonk how we want it to. But as I was saying, we can make our follow enemy move in a couple of ways. We can use physics like we're using for our player. Otherwise, we're going to do it the way I'm showing you now. And that's just going to be using vector 2. And we're going to skip over the physics, and we're just going to set our position to our vector 2. And what that's going to do is move us in that direction. So I'll get rid of all this middle stuff again. And we're going to make a serialized field. And I'm going to, give me a sec here. I'm going to make a private float, and I'm going to name this minimum distance. And that's because it's going to be the distance we need our enemy to get to before it's satisfied with its position. I'm going to make another serialized field, and it's going to be a private float, and I'm going to name it speed, because the speed we're moving our enemy at, similar to the player speed. And then I'm going to make a private transform, and I'm going to name it target. And then after that, we're going to do a private void awake. And inside this, we are going to set our target equal to our player movement script. So to do this, we're going to see target equals find object of type. And we're going to look for the player movement. And what this is going to do is it's going to look through our whole scene, and we are going to try and find the object with the player movement script on it. And since that's only going to be our player, this is a really simple way to set our target to the player. We also need to make sure we do dot transform at the end there, otherwise it won't work because we have our target variable as a transform. But anyway, we can continue, and we're going to make a private void update, and we're going to say if we have a target, we are going to check if our vector2 dot not distance, or is it distance, transform dot position, target dot position is greater than our minimum distance. So this is just going to check if our enemy is satisfied with its position or not. If we are above our minimum distance, then we're going to continue following, but if we've reached our minimum distance, then we'll stop. So to make our enemy actually move, we're going to do transform dot position equals vector2 dot move towards, and we are going to do Move towards is a very good function. It can cover a lot of basic movement scripts, but going on from that, to do move towards, we need our current position, so transform.position, and the position we want to go to, so our target.position. Needs me to capitalize it. And then we need to tell it the speed we want to move to that place at. So we're going to do our speed, and then we need to multiply speed times time delta time, just to keep it consistent so it doesn't change the performance based on the console once again. So with all of that done, our player should be moving. Or not our player, our enemy, sorry. But yeah, not too bad. And with that, we can just drag our follow AI onto the enemy, and I'll set the min distance to, we'll go with 1. And then I'm going to set the speed to, let's do also 1, just to keep it slow in the beginning. And you can see that our enemy is moving towards us, and it'll stop once it reaches that minimum distance. So we have a fully functioning guy, and we can go into our debug, and we'll see the player is our target, and we can also check our direction in the debug menu. It kind of just shows all the hidden values in your scripts. So really good tool to bear in mind in the future. Oh, give me 1 second here. There we go. Just keep in mind the debug menu. Very, very good tool to use. And seeing that, I can see that my player is rotating because we forgot to hit the freeze rotation on the Z. So I'm going to fix that really quick. I can go to normal and then see if I freeze it, it's all good again. And that could have caused us some problems in the future, but if I just hit, I'm going to set the player back to the starting position, and then I'm going to set freeze rotation to Z to true, so our player's not going to rotate anymore. But with all that done, we can then make the interactions between our player and our enemy, and this is going to be probably the most complicated part of the video, but once we get it set up, it'll be really helpful for us in the future. So it'll be, I think, 3 scripts, as we'll do 3 more today, and we'll probably call it there. But going from that, we're going to make a very, very basic script. It'll be a very small one here, and I'm going to name this Game Actions. And let's see, let Visual Studio load up here. And then get rid of all the middle junk again, the huge. And we're going to make a public float. Notice it's not a serialized field or private, it's a public float. That is important. I can explain the difference between variable types in the comments or in the future if you guys need that. But I'm going to name this delay, and we'll see that's useful later. We're going to make a public virtual, public virtual, can't spell, virtual void, and we're going to name this action. And yeah, then we're also going to make another thing, and we're going to name it d-action, and do this one more time, but we're going to name that reset action. And it's a very general script. This is all we're going to put in, and this is just going to be kind of what we base all of our game scripts off of. So when we want the player to attack, we'll put into an action, or when we want something to jump away, we can put it into d-action, and if we want to reset our starting position, we can reset our actions, but all kinds of stuff. Very, very helpful script to have. So make sure to get this right. And then going on from there, we have our game action script, but we have nothing to trigger game actions between the enemy and the player. So we can change that quick, and I'm just gonna, how do I want to do this? I'm debating which way to show you guys. We are gonna go ahead and do it this way. So we're gonna set our circle collider 2D to a trigger and make sure that is the follow enemies collider. And then from there, we're gonna make a new script. We're gonna name this script trigger game actions. And this is what we're gonna put onto our enemy to make it do what we want once we get into that portion. Now, this is going to be a bit of a complicated script, so hang in there with me, and if you guys need me to explain something more in depth in the comments, let me know, and I can do that for you. Otherwise, I also have a Twitter and Reddit, so you can message me on over there. But we're going to make a serialized field private, and I said I was going to explain this earlier. Serialized field, all that does is it makes it so you can see your variables in the editor without making it public, even if it's a private variable. So that's all a serialized field does. It's a helpful tool if you want to keep your variables private but still want to be able to edit them. So I'm going to name this B toggle, and that's a private bool, and that'll be useful in a bit. But we're also going to make a another serialized field, and I'm going to make a private list of game actions, the script we made earlier. So this is going to take in a bunch of those, basically, so we can have multiple actions on an object. And I'm just going to name this actions. And then along with that, I'm going to do a private bool, and I'm going to name this, give me a sec here, B active, and another bool, which is going to be B deactive. And notice these are private, not serialized, not public. It's not too important. It's just a variable difference. It won't break your code if you have them as a public bool or a serialized private bool. Only difference is what scripts can access it. So from that, I'm going to make a private void on trigger enter 2D. It's very important that you do 2D, and is also a trigger because we set our circle collider on our enemy to a trigger. If you don't have it as a trigger, the script won't work if it's a normal collider. So make sure to keep that in mind. Very important detail. Also very easy to miss since it's just a check mark. But anyway, going off of that, inside of our on trigger enter 2D, we are going to say if be active, we are going to return. And all this is going to do is if we are already actively doing our actions, stop. Or not stop. Don't do them again. Only call it once while we're doing them. And this is just going to make it so we don't repeat over and over. And then from there, we're going to have to make a quarantine. Or first we're going to set be action to true. Just to say, since we've gotten past our be active statement, we can say it's true. And then from there, we are going to go ahead and make an I enumerator, which is also called a quarantine. And I'm not too sure the best way to explain a quarantine at the moment, but we can continue on, and I'll try and give some examples later. But I'm going to name this execute actions. And then we're going to do a for each loop. And we're going to say for each game action in action in actions. A little bit of a silly naming scheme, but it's okay. We're going to say yield return wait 4 seconds, and we're going to say action dot delay, and this is going to wait the amount of time we put into our delay in our game action. And this is what the little thing that we had here. inside this other script. It's just the public float. So you can put in a 0, you can put in a 3. It'll wait the 3 seconds or the 0 seconds. It just helps a little bit if you need it. And we'll probably need it in the future. So good to have. And then the reason IEnumerators are special is because these are the only things you can use the yield return new wait for seconds. So yeah. And then we're going to do if be deactive, we're going to call action dot deaction. And if else, we're going to call action dot action. And from there, we can do be deactive equals false, and we can also do be active equals false. And this is just going to say that we are done with our actions and we are ready to do our actions over again if we need to. And with that, we can call our quarantine. So it's going to say start quarantine, execute actions. And this is just going to call our IEnumerator execute actions the same way you'd call a normal function. But these just have the fancy new wait for seconds that lets us do that delay that we want. So with that, we have everything we need for onTrigger enter 2D, but we're also going to do private void onTrigger exit 2D, just in case we want to call things when the player leaves a certain area rather than when it enters it. So we're going to say if be toggle, or if be active and be deactive, we're going to return. Give me a second here. I'm dyslexic, if you didn't know that. Makes spelling a little bit hard sometimes, but that's all right. So this is just going to run through all of our actions, and it's going to return if we're already doing our deactions. But we're going to say if be toggle, we are going to do be deactive equals true, and we're going to do start quarantine execute actions. And this is just going to allow us to call our quarantine when we leave a collider as well as enter it. So we're not going to use it today, but maybe in the future. With that done, we have everything we need to go through and trigger our interactions between the enemy and the player. So first, explain this a little bit. If we have B toggle, it'll also do the onTrigger exit 2D and go through and do execute actions twice. If we don't have that toggle, it'll just do it once. But anyway, we can do follow enemy, and then we are gonna add our trigger game actions. And you can see right now our list is empty because we don't have any game actions. So we're gonna have to make some. But now you can see that we can kind of phase through our enemy again too, just because it's a trigger, not actual collider, but that's okay. We'll adjust that in a second as well. But for now, I can also show that our follow AI will stop at the distance we want it to, so I'm going to just keep it at 1, but you can set it to 0 if you want it to be like on the player. If you can set it to 2 if you want them to just get close to the player, but I'm going to leave mine at 1 because that's what we need for today. But I'm going to make a game action that is going to apply knockback to the player, and I'm going to assign it into the actions list on the follow enemy. And all it's going to do is that when we bump into our player, or when our player bumps into the enemy, we're going to knock him back. And this is just a little example of what we can do with our player actions, or game actions. So I'm going to name it GA for game actions. Just a good naming scheme makes it easier to find our game actions if we're trying to add one. And I'm going to do GA knockback. And then I'll let our Visual Studio load up again. If you're on Windows, it'll be Visual Studio. I don't know what Linux has or other platforms, but I like my Visual Studio. It makes the letters a pretty color and lets me see where I have errors a lot easier. But with that, here we can open our knockback script, and then we're gonna make sure that we change from mono behavior to game actions, and this is just gonna let us do a couple of things. It's gonna let us do a override action, and that's gonna make a public override void action, and you can see over in game actions it's just gonna let us replace whatever is generally inside that, and we're gonna change it to something else. And that's what that base action means, is that it would do the normal action inside of the game actions class. But since we don't have anything, normally it would just not do anything. But that's where we come in. So we're gonna do a couple of things, and we're gonna do a transform, and we're gonna set it to target, or transform target. I need to do a capital T real quick. And we're gonna do transform target equals, and same thing we did with the follow AI, we're gonna do transform target equals find object of type, and then we also need the type, so we're gonna do player movement, and then from there we can set it to the transform of that object, the same way we did in the other script. And what this is going to let us do is just see what we're knocking back, and we'll see why that's needed in a second. Along with that, give me 1 second here. Just want to make sure I do it right for you guys. I'm referencing my scripts from Snack and Kraken to just make this go a little bit smoother. But we're going to make another quarantine, so we're just going to say start quarantine for now. We'll fix it later. And I want this to be a public IEnumerator, and I'm going to name it knockback, because that's what it's doing. We're going to knock back the player. So we need a float, a timer, and we're going to set that equal to 0. Then we also need a while loop, and we're going to say while timer is less than or equal to duration, and we need to make a duration variable, but we're going to do that inside of our enumerator. So inside these parentheses we're going to say float duration, and that's going to be a variable we have to read in, and we're also going to say float power, and also transform and we're gonna, oh my goodness, we're gonna do transform target, and we're just gonna pass in those things when we call the quarantine. But for right now we're gonna say while timer is less than or equal to duration, we want to do a vector2 dot distance, or vector2 dot vector2 direction equals target dot position minus transform dot position, and we want to make that dot normalized as well. It was auto-filling it for me, but I just wanted to make sure I did it right. And that's just going to make sure our numbers are nice, doing the dot normalized at the end. But reading in that is going to let us see what direction the player is coming from. So if the player is coming from the top left, we want to hit it back in the top left direction. Or if the player is coming from the bottom left, we want to hit it back in the bottom left direction. And that's why we have to read in or find the vector2 direction, and that's what target dot position minus transform dot position is. So with that, we're going to say rigid body RB is equal to target dot get component rigid body 2D. So this is just going to grab the rigid body off of our player, and we're going to say rigid body dot add force, and we're going to say add force in direction, and we need to multiply that by the power, so how strong we want our knockback to be. and we can do a yield return new, wait for fixed update, and this is just going to keep our game consistent again, is what the fixed update's doing. And then we're going to say timer plus equals time dot delta time, and that's just going to raise our timer while the timer is less than duration. So we're going to keep going through, and then now we need to make our variables up there, and we're going to get that all done. Our start quarantine, we're going to say knockback, and then we have to make our variables up at the top here, and we're going to do a serialized field, a private float, and we want this first float to be our power for how strong our knockback is going to be, and then another serialized field. Oh my goodness, here we go, another serialized field, and we're going to name that private float duration, and this is going to be what we pass into our knockback. So we're just going to say duration, comma, power, comma, target, and we got the target from our transform target up there. And with that all done, our player should be taking some knockback, but first we have to make sure to add our knockback game action into our list of actions. Otherwise it wouldn't execute them, because the trigger game action is what's doing it. It's what's calling it. So without that, it wouldn't do it. And from there, I'm not going to have a delay. We don't need that for this. I'm going to do a duration, 0.2, and a power we'll set to something like 70 for now, just to get some good old knockback going. But with that done, you'll see when the enemy runs into me, it knocks me back a little bit. Not the most crazy amount of knockback in the world. And what we can do to change that is we can double it and set it to, or set the power to 1, but the duration, there we go, 120, but the duration up as well. So now you'll see I get knocked back a little bit, but it's a pretty slow knockback since our duration is 0.6. So it just doesn't feel quite right. And we can just keep playing around with these numbers until we get a result that we want. With that said, I'm going to set mine to an insane number like 2,000, and you'll see that this is going to send us absolutely flying, and that's a little bit drastic for what we need. So, sorry, I just think this is kind of funny. We are going to change that from 2,000 to a smaller number, and we'll also maybe change our duration around a little bit. We'll see. Let's go with half that and say 1,000, because I did kind of like the speed it was going, but yeah, I think that's all right. 500 seems a little bit more reasonable. Yeah, that's some good knockback. And this will happen anytime we run into the enemy. It'll just give us a little bit of knockback. But that was about everything I wanted to cover for today. Just making the 6 scripts related to the player movement, the enemy movement, and then the interactions between them. Next week, we'll probably focus a bit more on visuals. So I'll teach you how to work with tile maps, which are very, very nice for 2D. It lets you do all kinds of things as far as making different beautiful environments, but doing it very quickly and very simply. And then on top of that, we will probably add a couple of sprites to our player and our enemy. And I'll probably just snatch an asset pack for that, and I'll show you guys this asset pack when I decide which one we're going to use. But with that said, thank you very, very much for watching,